All right, so in this presentation, we are going to look at two concepts. The first one, which is measures of disease occurrence, and then the second one is measures of association. Remember that we actually look at the association between diet and health outcomes. In nutritional epidemiology, that is the goal. We want to understand how diet influences health outcomes. So to do that, we need to first be aware of the basics of measures of disease occurrence and then measures of association. So let's start. The measures of disease occurrence are basically about describing how diseases are occurring in a particular population. Often we have two major ones that we actually use, but of course there are others that we have not included in here. The two major ones are incidence, which is basically the number of individuals with a new disease. Okay, so for example, you have 50 individuals, and then in those individuals, let us say 5 develop, let us say, malaria. So incidence would therefore be 5 for these people. And then the other concept is prevalence, the number of people who have a given disease in a given population at a given period of time. So that is prevalence. And then you can actually decide to look at the number of people who develop a particular disease in a given period of time. So maybe in a period of 1 year, how many people have developed hypertension? That is what we call cumulative incidence. Now let's move to the measures of association. Measures of association. Measures of association refer to how do we quantify, how do we quantify the relationship between a given health outcome with a given risk factor? What are the chances that a person who takes sugary foods will develop diabetes type 2? We want to understand the chances, because understanding those chances can allow us to plan accordingly and institute measures to address particular risk factors. Okay, so the first measure of association is what we call relative risk. Relative risk, you're just basically comparing the risk of developing a particular disease in people who are actually exposed compared to the risk of occurrence of a given disease in people who are not exposed. Okay, so that means that you calculate incidence in the people exposed and then the incidence in people who are not exposed. Okay, so in this case, you have, for example, if you have 50 people who take sugary drinks, and then you have 50 people who don't take a lot of sugary drinks. Out of those who take a lot of sugary drinks, let us say 20 develop diabetes type 2. And then on the other side, only let us say 10 get the diabetes type 2. So when you calculate the incidence, it means it is 20 over 50, that is the incidence in the exposed. Divide it with the incidence in the unexposed, which is 10 out of 50. Okay, so you have 20 over 50. The whole of the answer you get there, you're going to divide it with 10 divided by 50. So the answers you get will give you information on whether taking sugary drinks will increase your chances or not. If you get an answer which is more than 1, If after dividing you get an answer more than 1, it means that the chances of developing diabetes type 2 are high if the person takes a lot of sugary drinks. Okay, if you get an answer which is less than 1, it means that if you take a lot of sugary drinks, you do not have an increased chance of getting diabetes type 2. So that is the first measure of association. The second measure of association is what we call odds ratio. Odds are basically about probability. What are the chances that what are the chances of occurrence of a particular disease after exposure? Okay, that's what we basically mean. The interpretation is basically almost the same as that of relative risk. Okay, so we shall look at the calculation of that shortly. And the third one that we are looking at is what we call hazard ratio, which is basically how many people are going to get a given disease after exposure to a particular hazard. Interpretation remains almost the same. Then the last one is the attributable risk, which is basically looking at what are the chances, okay? What are the chances that a particular risk factor contributes to the occurrence of a particular health condition, okay? So it provides us with very good information on the contribution of the risk factor to the occurrence of a particular disease. Let us say, for example, diabetes type 2, or diabetes actually, has many contributory factors. It could be a genetic factor. It could be a lifestyle factor. But how do you determine, or to what extent are these factors actually contributing to diabetes? So you can calculate using what you call the attributable risk. So how do you calculate the attributable risk? We have an example here. You have 500 people. One group takes a lot of sugary drinks, another group does not take a lot of sugary drinks. So those who take a lot of sugary drinks are 200. Those who take less are 300. So you follow them for a period of 10 years and then see who develops diabetes type 2. You see that in this example, 50 people out of the 200 will develop diabetes type 2, and 30 out of the 300 will develop diabetes type 2 in the people who don't take a lot of sugary drinks. So to calculate the attributable risk, you need to get the risk in the exposed group, which is basically the 50 out of the 200, you get 0.2. Then also you get the risk in the unexposed, which is basically 30 out of 300, and then get 0.1. So you need to subtract the risk in the exposed minus the risk in the unexposed. It will be 0.25 minus 0.1, which you get 0.15. The interpretation is that since it's a positive figure, you realize that the chances of getting diabetes type 2 are increased because of taking sugary drinks by 15%. So 15% is the chances that you can actually develop diabetes type 2 as a result of taking sugary beverages. So in practice, you will have you will have a decision to make. How do you decide which measure to use? You need to look at the nature of research question that you have, the design, and what is actually your interest. What is research question are you trying to answer? If you know that, then you will know what measure to use. Remember, we have talked about odds ratio, relative risk, attributable risk, and then hazard ratio. So how do you make that decision? The interpretation remains basically the same, that if you get more than 1, it means that there is the exposure is actually increasing the risk in the exposed group. If you get a negative figure, it could be that the exposure, or actually if you get less than 1, it means that the exposure is actually protective. So you need to understand that kind of interpretation. There's another concept which we call the confidence interval, which I think you looked at in biostatistics, which is basically you need to make a decision on what range should the true value be falling into, what category or what range, actually, what the range of values that the true measure of the association is likely to fall. So you need to make a choice, but you look at this in details in biostatistics. Now, the other problem that you have to sort out is the problem to do with the confounding factors, which I explained that you could have other factors that affect the health outcome of interest and you've not taken care of them. You take care of them by statistical methods or analysis, such that you control the confounding factors. So we have an example here that calculates the odds ratio and then the relative risk. So here you have a group of people who take a lot of the diet with the adequate fiber, and then we see who out of those who will develop cardiovascular diseases. Okay, so we have those who take less than 20 grams, and then those who take more than 20 grams. Less than, and then less than and more than. Okay, and then we see who develops the disease. Okay, so you have that table there. So don't need to forget the figures. I mean the formula, the different formulas for relative risk, risk ratio, odds ratio, attributable risk. Don't forget those. Basically, if you know the formula, then you just feed in the values. Okay, know the formula, feed in the values. So the values is just automatic, as long as you need to draw this table. This table is what you call a 2x2 table. Draw it very well. The risk factor and then the health outcome. Yes or no? Is there a risk or there is no risk? Put those figures properly. The way this table is, you will not get any difficulties in calculation of relative risk, odds ratio, or risk ratios. Okay, so this is what basically it looks like. I'm actually going to end here unless you have any questions.